let's finish up these slides about arrays and vectors. Let's do it. So let's see if there's anything I need to give you today. No, it's just the lecture. Just the lecture. We'll make it through. All right, so we ended up last time talking about how to reverse an array or a vector in place, so not changing anything, just like going through indices and swapping them. We noticed that we could swap from one end to the other. If we did that a certain number of times, it would become reversed. It's always half the size. Size over 2, integer division. Even versus odd, doesn't matter. So let's actually code that this time. Let's code it up and talk about it. All right, so remember our strategy. We're going to iterate through a vector, starting with an index, usually. So that iteration, I have to undo my pen stuff. Let me fix that. It's so odd. Oh, that's better. All right, so we're going to need to iterate through our vector to change things around. So here's an example, vector / array. It works for either one. So let's say we have 6 things. 1, 2, 3, 4, 5, 6 indices, of course, 0, 1, 2, 3, 4, and 5. And what are the initial values? Let's say, I don't know, some garbled mess here. It could be any order. We just want to reverse it. 7, 2, 3, 4, 5, 6. I don't know. Doesn't matter. Let's see here. So that could be our example. And what we're going to do is we're going to iterate size over 2 times. Let me zoom out of the way. And do the following. So we're going to have an iteration variable, I, start at 0, like that's the first index that I want to start swapping something with. And what's the other side of that? I want to swap this guy with this guy over here. Just for fun, let's make it odd size, just so that we see it doing weird things in the middle. Let me expand this. And I think what I meant was to just do 1 through 7 or something. Let's do that. So here's my example vector / array. And I'm going to start at index 0, and I'm going to try to swap that with index 6. How can I calculate index 6? Do you remember that? It's going to be, the last index is always going to be your size minus 1. Size minus 1 will give us that. That's the first thing to do. And notice that if you do it like this, it'll always work. Because that's the first thing I need to swap. Swap indices 0 and 6, and then it's 1 and 5. You do I++, make I 1. That'll always be the left side of the swap. How do you get the right side of the swap? It's always going to be, you started here at size minus 1, move in 1 more. Move in I. See that? So the right index that you want to swap with is, well, if your left index is I, like it's 0, it's always size minus I minus 1. Or size minus 1 minus I, however you want to think about it, because you're starting there and you're moving inwards. You're subtracting your I. That'll get you the other side. Just like when I becomes 1, then you'll get index 5 correctly by calculating your size, which was 7, minus I, which is 1, so that gives you 6, minus another 1 gives you 5. So it'll bring it inwards. See that? Size minus I minus 1 is the trick. Okay? Then we make like I2. That'll calculate, all right, I want to swap index 2 with size minus I minus 1. So size 7 minus 2 minus 1 is index 4. So that'll always give me the right side, the right index to swap with. That's exactly what I want there. And that is perfect. All right. Even if it's odd or even, doesn't matter. It'll always do the right thing. And then we just want to make sure to swap at each point. So 7 and 1 and 6 and 2. And then 5 and 3. And then we only do it size over 2 times, so we don't do anything for the middle. It doesn't need to move. It doesn't need to be swapped with itself. Okay? So we're going to keep on iterating as long as I is less than size over 2, because I want to do size over 2 swaps exactly. And if I starts at 0, if it goes strictly less than, it will do it that many times. Okay, so let's code this up. So for example, we're doing it 7 over 2 integer division times, which is 3 swaps total. Okay? And so remember, like, to use your temporary variables when you're swapping 7 and 1, for example, like you got to put the 1 somewhere for a split second so you don't lose it. And let's code it up. Alright, how do I want to do this? Let's call it reverse.cpp. And let's reverse a vector. Why not? This will work exactly the same for arrays, though. So, alright, let's make that vector of ints. Call it v equals 1 through 7. There it is. Now we have it. And now let's swap it a bunch of times. Let's iterate. Alright, so let's do for int I equals 0. I is less than. I want I to be the left-hand side of every swap, and I want to do size over 2 swaps. So I is going to range between 0 and size over 2, not including that, though. Strictly less than. Size over 2, that'll iterate exactly size over 2 times. I will change and be size over 2 different values. This loop will iterate size over 2 times, which is exactly what we wanted. And we want to do that many swaps. So swap the thing, right? Swap the thing at index I with the thing at index size minus 1 minus I. Indices I and size minus 1 minus I. Think about it however you want. I said it different on the slide. But the very first time I is 0, that's our last index. Then when I is 1, we're swapping index 1 with the second to last index. It's always being moved inwards. We're subtracting I. Okay? So let's calculate that index. Why not? Int index to swap with equals v dot size minus 1 minus I. And then, let's do the swapping. So size minus I minus 1 or size minus 1 minus I. Maybe that's an easier way to think about it. Let's change that. Now I want to swap the thing at index I with the thing at index to swap with. I just calculated it. All right. The setup is, got to use that temporary variable. Temp equals the first thing, v at I. Then now we're safe to get rid of v at I. We've saved it away. Make it the other thing. Make it v at index to swap with, the other side. And now we can replace that other index, that right side index to swap with. Make that, temp. And that will correctly do the swapping of the values at those indices, at index I and index to swap with that we calculated. Okay? So by the time this is done, we've gone through and swapped size over 2 times, doing the strategy we talked about. The vector has been reversed. We can verify that by going through it for every element in V, print it out. Let's see if I can get all the relevant code here. It looks like it. Nice. And this is doing it. We get 7654321. Any questions about that? Is that making at least a little bit of sense? Yeah. I cannot. I don't know how. I don't. Either they come on or they don't. We can try them. So I guess you can log into my Zoom and do it that way, but let's see. Let's see if I can try. I think this is the dusty remote. That's really makes us all. Really starting to think it does. Seriously. Alright, any other questions? And this will work regardless of the size of the vector. If it's odd, if it's even, doesn't matter. Go through 8. Totally fine. It'll calculate that index. It'll swap exactly as many times as it needs to. Okay? That's reversal. Fun. It's a pretty complicated algorithm. We got it. Alright. Now I have a question for you. So please get into maybe peer instruction groups. And I would like you to, I guess, you can write it down if you want. Why not? Let's go to the written ice page. This will be fun. You don't have to write code, just write like the strategy. I'll clear this out. If you're feeling brave, please post here. But here's what I want you to think about and try to write down. Write down how to do each of the following for both arrays and vectors, because it's different for each, right? How do you access an element at an index of a vector and an array? It's different. How do you initialize a vector and an array to hold 1, 2, 3 in that order? There are some different ways. Just pick one. See if you can remember. How would you make a new array slash vector of size 10, making it hold 42 at every index? How would you do that? You could type it out, I guess, but maybe you could use a loop for at least the vectors. You can just write the English version of how you might do that. But these are a bunch of different things that you could do, and arrays and vectors work differently. Do you remember the syntax? Do you remember the strategy? So take a couple minutes, try that. Post your answer if you would like. But I will tell you the answer in like 3 minutes. One minute per bullet, I guess. Then I can work on the TVs too. Oh, no. Alright, I'll try another one. That one. Still nothing. That is the last potential slot. Still nothing. Sorry. I'm trying to fix something else broke. Should have done that. Still not. Just use Zoom, I guess. All right. Were there any questions that came up as we were trying this? Let's see. Did anybody say something? Thank you, Group 73. Proud of you. So yeah. So let's see here. For arrays, it would be those angle brackets, something like this to access things. And nice for vectors. You would use the dot at for vectors, for example. So thank you all for writing things down, or at least thinking of them. Please do attendance. I'm going to stop that in just a second. Let's talk about both ways. So access an element at an index. So for arrays, if you have an array, you have to use those square brackets. Go to array at some index. For vectors, instead of that, you use v.at, right? Use the .at operation, .at of I, some index. Let's see here. To initialize to hold 1, 2, 3, I guess the easiest way would have been like int r, and you can either give a 3 here or not a 3 here, because it doesn't matter. If you give it all at once, you don't have to give that 3 there. But you could if you wanted to. 1, 2, 3. That's how to initialize an array, probably the easiest way. And then a vector of ints. Oops. Call it, I don't know. Call it v. You could start it off empty. You could be like v.pushback 1, then 2, then 3. Because vectors can be added to. They can grow, pushback stuff. That's possible. Or you can just, like, in one fell swoop, just set it equal to 1, 2, 3, just like for arrays. That works. That's also fine. Let's see. How would you create a new array / vector of size 10 holding 42 in every index? I guess for an array, the easiest way would have been something like just write it all out. Equals 42, 42, 42, blah, 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 10 times. You could have used a loop, though, made an array of size 10, iterated through it. Vectors are kind of cool in that you can do this. Vector int. There's a way to build a vector. It's called a constructor for a vector. If you just say its name and then pretend it's a function, if you give a number and then a value, it will put this many of these values in a vector. It'll just make it for you. It'll make a vector of 10 42s. Kind of cute. So that's a secret way of doing all that. But yeah, those are your options, kind of. Any questions about that? Just there's a difference in syntax. Hopefully it's making its way into your long-term memory. So that is, that's that. Yeah, if we're happy, I'd like to talk about a special kind of array now. They're called C-strings. They're beautiful. They're the way that strings were represented for the C language, and the entire Linux kernel is written in C, and so like the entire operating system on the class server is working with C-like stuff at the end of the day, and so for certain things you have to use C-level values. So we have to talk about C strings. The string library that we know and love, that's C++'s version of strings. That's C++ strings, let's say. It's different. C strings are much simpler. They're just special kinds of arrays. All right. Let's talk about that. Yeah. So a C string is an array with a special ending value. It's an array of characters. So normally we prefer to use our C++ string data type, but sometimes if you want to like interact with the operating system that's written in C, you got to use C strings. So that's why we're learning this. A C string is a special kind of character array. Special kind of character array. And so here is a character array that is not a C string. It's just HELLO. You might think that's a string, like it's characters, why not? But it's not a C string because to be a C string, you need a special ending value. It's the \0 character. It's called the null terminator character. And this is how a C string knows when it's done. This marks the end. So you need that. Marks the end of the C string. Alright, so that is a C string, but this other one was not. You need that \0. That's called the null terminator character. It tells you when it's over, because arrays don't know their size. And so as C++ is, or as C, as the operating system is trying to print something from a C string, it's like, when are you done with the characters? It'll just try to like read the next one, read the next one, read the next one, and print it out. It knows it's done once it sees this. That's why we need that. Okay? And nobody wants to write this all day long, just every character separately. So actually, when you did this syntax, when you made like normal C++ strings, this syntax right here with double quotes, it actually makes a C string. It was getting converted to a C++ string for you when you put it into a string variable. But secretly, this is shorthand for an array of characters with that special null terminator at the end placed there for you. Okay? That's a little weird, I know, but hopefully that makes a little bit of sense. So that's that. The null terminator character is what that's called. \0. And so deep down in memory, like you make this, it really does become an array of characters that has H, E, L, L, O, and then secretly an extra thing, \0. And C++ knows how to print them. Like, you can give to cout a C string and give the str array, and it's happy to print it. Totally fine with that. So yeah, the type of a C string is char bracket bracket kind of type of a C string. It's not string, it's char bracket bracket. And for reasons that we will get into later, this is equivalent to char star. If you put a star, it also means an array of characters. Okay? For a very weird reason that it'll take a while to explain. All right, we'll get there though. That is C strings. Let me show you some of them. Where do I want to be? I will make a new file called cstrings.cpp. All right, so yeah, let's just make it happen. Char s bracket bracket equals. This is a C string. H, E, L, the L character again, O character, and then that special null terminator \0 character. All right, so this is a C string. But nobody wants to type it like this all day long. Instead, we'll use the shorthand, char s2, we'll make this other string, using just this. That's exactly equivalent. Shorthand for the above. So that's pretty nice. And C++ knows how to print all these things. Be like cout s2. And it is happy to print a C string for you. It knows. It knows how to do it. So there it is. That's a C string. Cool. What else could we do? Let me show you some library functions. There's a whole library written for C strings. It's called the C string library, aptly named. Also, the C standard library has some C string functions in it too. We'll talk about that too. But yeah, let's go there. C string. I want to be here. C library. Where did it go? C library. C string. That has a lot of cool stuff. And then also the C standard library, cstdlib, that we know and love already for random stuff. That also has some C string functions. So the first one that I'll teach you is in the C standard library. It will convert a C string into an integer, right? So let's do that one. This will convert a string 4 like into the number 4. All right, so we'll use A2I to do that. You click on it. It's like, all right, how do you do it? It takes a C string, char star, and it gives you back the int form of it, assuming it really was a string that represented a number. So let's make a string that holds a number. Char s3 bracket bracket, have that equal the string 42. Remember, that's not the number 42. So now I could be like cout A2I s3. It will convert it, and then I could do math on that times 2 if I include the C standard library. Question, yes?
Why are we not just like casting it as you would traditionally because these strings have to be changed to an integer like this?
Any string has to be done like this. You can't cast a string to an integer. It doesn't get converted automatically, at least in C++. Yeah, it doesn't work. You have to call a library function to convert. And so here we are, converting 42 to the actual number 42 with this A2I call, and then we can actually do math. We get our 84, okay? In C++, you also have the S2I function, which takes strings, C++ strings, and converts those to numbers. So you could use this as well, because any C string can be up-converted to a C++ string. All right, so there's that. There's that one. Let's talk about strcat. These are all just like, they like to really shorten the names of their functions in the C library. So strcat is essentially the plus operation on C strings. So here's how it works. Essentially, if you call strcat, it takes 2 strings, S1, S2, and it like plops the first one, or the second one onto the first one. So this is equivalent to the C++ strings, S1 equals S1 plus S2. We don't get that. We have to do it this way. So it's like adding S2 to the end of S1. And so you better have some extra space at the end of S1 because it is an array after all. you better have some extra space at the end of your first string if you want to use strcat. And this lives in the C string library. So let's go back to there. There it is, strcat, concatenate strings, that's what it's trying to do. So it's like you have a destination and a source, those are both char stars, so C strings, and it'll also give you back like where it made it, but we know it's going to destination anyway. So there's that. Alright, so let's run that, let's do strcat. So let me make a string, char S4, and like I want to add something to the end of it, S4 equals high or something like that. And then, like, let's say I want to add mom. Make the string hi mom. Char S5 bracket bracket equals mom exclamation point. So right now I cannot call strcat S4 S5 because there's a problem of sizes. I need the C string library anyway. If I call strcat right now, remember what it's trying to do. It's trying to say S4 equals S4 plus S5. That's how we think about it. There is no room at the end of S4 for these characters in S5. You see that? We only have room for 3 characters in S4 in the null terminator. We can't put anything else. It'll mess it up and like start writing to memory that we don't get access to. So to make space in S4 for those extra characters, you can do it this way. You can say S4 and give it a size that's bigger than what it's about to be given here. That's totally allowable. And so there will be empty space at the end of S4, room for other things. It's really going to be an array of 50 characters. I'm going to give you 3 and then the null terminator right now, but I'm going to fill it in later with extra stuff. That's your promise to C++. So now it's going to work. Now it's going to build up that S4 into something bigger, and we can print it out. See out S4. It's not C string land, another thing that you might want to do. And so we've built out that bigger string. Now S4 holds hi, space, mom, exclamation point, null terminator. It moved where the null terminator was, and so now it knows that. It's done when it sees that one. All right? Questions about strcat? It's a little weird. Here's a very easy one. Strlen. That gives you back the size of a C string. Where's that? That's somewhere here, I assume. Strlen. There it is. Get string length. It takes a string and gives you back its size in a number format that can never be negative, but we can just make it an integer. Not a big deal. Strlen tells you the size of a C string because it's just going to loop through and find the null terminator. It's going to start counting characters. See out strlen. So eventually you'll be able to make your own version of strlen. Strlen S2. How big is S2? It's the hello string right here. That's what S2 is. How big is that? It'll tell you. And so it says it's 5 characters. But remember, it's not counting the null terminator character. That's one caveat of strlen. It thinks you don't care about that. It doesn't count \0. Just assumes you know that's going to be there anyway. So really S2 is a size 6 array, but the string itself is length 5, it assumes. So that null terminator does not count as like part of the string. It's like an ender for the string. It marks the end. All right? We're good with those first 3? Because the last one is the weirdest. It's called string compare. It compares 2 strings, and it doesn't give you back like anything normal looking. It does that dictionary order comparison like we were doing for C++ strings, but it doesn't give like true or false back, like one's less than the other. It gives numbers back. It's very odd. So if you call strcomp on 2 strings, if the first one was less than the second one, so like it came before it in the dictionary, then it returns a negative value, some arbitrary negative value. Could be -1, it could be something else. If the 2 strings are equal, then it returns 0, which is weird in itself. And then like there was 0 difference between them maybe. And then if the first string comes after the second string in the dictionary, it returns a positive value. So you're getting back numbers. It's very weird. Okay? So like, for example, if I give it AAA and AAB, it's going to try and figure out, all right, which of these come before each other in the dictionary? Compare the A's, compare the A's. Oh, the A comes before the B, so I'm going to return a negative value if I do the comparison in this order. It's very weird. It's like subtracting ASCII codes, essentially. That's how it's implemented. So that's why it looks a little odd. But you may need to do that comparison one day, so now you know how. Compare ABC to like BCD. And then let's compare, let's do it backwards. Let's do BCD and ABC. And then let's compare ABC to itself. Oops. They're equal. And then, let's just compare some random strings. Hello. Again, they're smaller. So let's see what it returns and gives back. And oh shoot, I want endls at the end of all of these. Sorry, endl, better. All right, so it's gonna give back some weird looking values, either positive or negative. All right, the first one's negative, so that means ABC comes before BCD in the dictionary. The second one's positive, that means BCD comes after ABC in the dictionary. These are equal, so it gives back 0. And then hello comes before hi, hi space mom apparently. And so that's a negative value. So very weird. So you can't use this in an if statement like you might think you can. Like if you want to check if they're equal, you got to be like, is the str compare returning 0? You got to check for equality with 0, not for like true or anything weird, or anything normal like that. Okay, does that make sense? Very weird, old style stuff. And then I guess I wanted to draw a diagram for this. Like I made extra space for this S4. What it did was it made S4 and it had 50 indices, had space for 50 things. I just filled it in a little bit. I filled it in with the string hi to start. So that was the H, the I, the null terminator. And then the rest was empty, but it was there. We made that memory for ourselves up to index 49. Starting at 0, of course. So that's what I did with S4. And so now there was room for that extra stuff. That's how that worked. Okay? So yeah, I think that's all the C string stuff I want to tell you about. You might need all this one day. Are we ready for a good actual use of C strings? Like this is all very vague and arbitrary. Could have used C++ strings for any of this. Let me show you one time where you were forced to use C strings. It is called command line arguments. All right. Notice that we have been running our programs like this. We've been saying // name of the program, hit and enter, right? But we've run other programs in a different way. We've been like G++, that's the name of a program. We've been running that, but we gave it things. We were like a.cpp, space separate that, -OA. It's just a terminal program. We've been writing terminal programs too. We've been saying cd, like tilde, give it some places to go. And so all these things after the name of the command, we've been missing out on. We would like that too. We would like to, just like G++, be able to put stuff after our program and get that information from the user. See what they type to us. All right? So it's called command line arguments. And our program can secretly see everything that we're giving it on the terminal. Like I can run this C strings program with hello, hi, 1, 2, 3. I can give it command line arguments. It's just not seeing them right now. It's not using them. But it has them. It knows where they are. So let's make programs that like can accept these things and like use them and make them do cool stuff. Change how the program works. All right? So the secret is the way we make the main function. If you want access to these things, these cool things, so it could be like /prog 42 hi, then we need to declare the main function anyway. Oh, and by the way, it's called command line arguments because you think of like your program as like you're calling a function. Pretend, essentially your program is a function at that point. Pretend prog is a function, and the rest are the arguments to it. Function. Like pretend G++ is a function, I guess. So it's like we're calling prog with 42 and hi, but the terminal wants it all space separated. Okay, that's my aside for the day. So we normally declared main and started implementing like this: int main parenthesis parenthesis. There's our main function. If instead you do it this way, then you get access to the command line argument. So instead of saying int main open close parentheses, this could be expanded upon. There's some room in those parentheses for some extra things. So int main, if you do it this way, you'll get command line arguments. So if you want them, you need 2 things. The first is an int, and it's commonly called argc. Int argc, it's got to be in this order in these types. The names can be different. Usually it's called argc though. And then you do char star argv bracket bracket. It's very ugly. And if you make your main like this, you're getting command line arguments. It can see them, all right? So let's start talking about what these are. They got to be in this order. This is the type for the second thing. You can give them different names, though, but these are their common names. argc tells you how many command line arguments you were given. All right, so this stands for your argument count. That's what it's short for. It's just the terminology that people chose once upon a time in the 70s. Arg count. That's how many you got. And then argv stands for your argument vector. This was before C++, and so forgive them. It just means an array. It's an array of all your command line arguments. But argv stands for argument vector. It's not really vector, though. Not the one we know about, right? So this is a very weird type. Char star bracket bracket. What is this? It's giving you all your command line arguments separate, and this is how it's doing it. argv, I'll use color coding. argv is you kind of read it backwards. It's an array of C strings. So the bracket bracket means it's an array. So this part, it's an array. Let's make this larger. It's an array. That's what the green part means. And then it's an array of C strings. That's what char star is. So I'll make that red, I guess. It's an array of C strings. That's the whole thing. Char star means C string. Okay? An arrays don't know their size, and so that's why you need argc as well, to know when it's done, how many you got. Together, though, argc tells you how many command line arguments you got, and then argv, if you index into it, it will give you each one of them separately as a C string. All right? So this is very weird, but let me show you an example, and that should help, I think. So let's get all of our command line arguments. So let's see here. Here's how they work. Let's make a program that just prints out our command line arguments and argc as well. So first of all, if you zoom in here and see what I'm doing, command line arguments don't care how much space is around things. Just as long as they're space separated, it will get stuff. It chops off spaces anyway. So for example, if we make a program, we compile it and call it prog, and then we run it like this, /prog 1 2 hi mom. When we make our main function this way, argc will be set on this particular run to 5. All right, it's actually counting the name of the program as an argument. Technically, it counts every space separated work. So argc will be set to 5 when we do it this way. Then argv will be an array of every one of those space separated things. So argv will be set to 5 things. /prog, the C string 1, C string 2, C string hi, C string mom. Right? These are all C strings. So if you want these numbers as numbers, you better use A2I or something. But that's what's going to happen. When you run it this way, argc will be 5, and then argv would be set to this. It's an array of C strings, every one of those that were space separated. Okay? This would be index 0, index 1, index 2, index 3, index 4. So usually you don't care about the name of the program. So the first argument that you care about is usually at index 1 of argv. Okay? So that's what's going on. So let me make a program that just iterates through every command line argument and prints them all out. I'll show you how it works different depending on how many you give. So let's give that as an example. I'll call it command line args.cpp. And so now, instead of making main this way, I'm going to give it those command line arguments. So int argc, char star argv bracket bracket. Very ugly. So argc, remember, that is your argument count. It tells you how many command line arguments you got. Number of command line args. And then argv, that's your argument vector. Argument vector. It's just an array, though. It's the contents of your command line arguments as C strings. That's the goal. All right. So secretly, argv is an array of C strings. There. All right. So now, if I run main this way, it's getting access to those things. So I have access to argc. Let's print it out. What was argc? It was whatever it holds. And so we can also iterate through argv because we know how big it is. argc is telling us the size of that array, how many command line arguments we were given. So let's iterate through argv. Let's iterate through argv. And so how about a for loop? So for int I equals 0, that's the first index. I is less than argc. Argc is the size of the array, so I want to go one less than that. It's the last index. I plus plus. Let's print out argv of I in a pretty way. So see out argv of I was colon space whatever it actually was, because we can just give a C string to see out and it'll be happy with it. So there I am printing out what was in argv, one at a time. And that's it. Now I'm using them. So let's compile. And now suddenly, I can run my program the way we usually did, command line arguments, but it's getting everything now. It's like, all right, when you run it just by itself, argc was 1, because there was one thing that you gave it, just the name of the program itself. And then argv had only one index, index 0, that was holding that string. But if you start saying stuff, you're like, I don't know, hi mom, space, 1, 2, 3, space separation, doesn't matter. It'll get them all. So argv was 6 for this. 1, 2, 3, 4, 5, 6 space separated things I gave. So argc is set to 6, and if I iterate through every index in argv, I'm getting all of those things. It's chopping off the spaces for me. Hi mom, 1, 2, 3. It's different every time, right? If you change it, argv is changing. argc is changing. It's a new way to give input to a program before it starts running. It's kind of cool. Any questions about this and why this code is doing that? It's just a secret extra thing you now have access to. But it's got to be C strings. That's what's being used here, yeah.
What does char represent?
It means C string. That's the type of C strings. The normal way to write it is when you're making one, it's char bracket bracket. But char star is equivalent to char bracket bracket for our purposes here. Yeah. It really means a pointer to a character, but we have not talked about pointers yet. We'll get there. Yeah. Any other questions? We doing all right? Okay. So, yeah, that's iterating through the command line arguments. Let's make a program that uses the command line arguments to do something. Let's make a program that draws a square of a certain size when the size is given in a command line argument. Let's do that. That'll be fun. And so we want to make a program that's like, call it draw square, and if we run it like this, /draw square, with like 5, it'll draw a 5 by 5 box for us. Isn't that fun? That's the goal. So let's make that. Draw square.cpp. Alright, so I need those command line arguments, int argc, char star argv bracket bracket, don't forget. And then, can you guys please talk on Discord? I can't think when I hear your voices. Thank you. Alright, so now I have access to those command line arguments. Alright, I have something. I need the size of my square in this command line argument. I'm getting it. It's an argv of, this is argv of 0, this will be argv of 1. If I go there, I'll get my 5. So what is that number that is the width of my square? It's sitting in argv of 5, but it's a C string, sadly. And so if I actually want this as a number so I can make it an int, like it's gonna not even compile right now, it's very confused, I need cstdlib, and then I need to convert A to I. That's what I want. All right, so now I actually have the width, and I can do my box drawing now. Oh, sorry, argv of 1, excuse me. I was getting the 5. It was in index 1. Sorry about that. So yeah, index 1 is where the number is somewhere, whatever it is, and then I'm getting it, putting it into the width variable. And now let me draw a width by width box with that doubly nested for loop that we probably hate still, but we're getting used to it. I is less than width, I plus plus, and then we'll do a j, right? J equals 0, j is less than width. I place with j, and then we need another curly brace there, and it's not happy, now it is. So I want to print a single star that many times on a single line, and then a new line to break it all once I'm done there. And so that'll print my box. But I got the width from the user before the program started in the command line arguments. That's the beauty of it all. So let's do that. Let's compile. draw square, dash O draw square, and I need to be careful now. I need to make sure to call it, to run this program, always with a number here, 5. And there it draws a 5 by 5 box. I can call it draw square 4. Draws a 4 by 4 box. 2 by 2 box. Isn't that fun? Any questions about how I'm using argv here? To get the number before, like I even start, the terminal's given it to me, and then I just run with that value. It's beautiful. All right. There are some issues though, because I could have said draw square by itself and have forgotten that number, and then what's an argv of 1 right now? It has nothing. It's undefined behavior, so we don't want to do that. It's probably going to make a giant. Okay, it's going to even have a runtime error, so we don't like that. So instead, let's control the fact that if I want this program to run, what should argc be set to? Like if I got an actual number from the user, what should argc be? Remember that's counting things. Counting how many things we got from the user, how many things do we want?
Are you talking about like by default or like
When we're for this particular program, I want it to be run exactly like this. Very good. Yeah, I want 2. I want argc to always be 2, because if it was 1, they only gave the name of the program and I didn't get a number, I can't do anything. Or if they gave more, they really messed up. I don't know what they meant. So argc should be exactly 2 for this program. Good. Should be 2. So we should check for that. And then we don't do anything where we can't have a runtime error in that case. It'll be much better. All right. So argv of 1, we need that to be there, and that requires argc to be at least 2. Argv of 1 holds our width of our box as a C string, so we had to convert it to as a C string. All right, so let's ensure that we got the right number of arguments from the user when we're drawing that square. And we can do that pretty easily. Before we try to access argv, let's have an if statement. Let's make sure if argc is bad, let's stop the program. If it's not 2, we're done. All right, so cout, you must, let's yell at the user now, you must run with a single number, exclamation point, new line, something like that. And then a cool thing about the fact that you always get the name of the program is you can tell the user how they should have run the program. It doesn't even matter what they called it. We can get that in argv of 0, because that always exists. So here's how you should have used the program, user. Usage, argv of 0, and then like space n, where n is a number. We're getting the name of the program from the user, because they could have renamed it, and then we should always stop the program. So we already have stdlib installed, or imported, so let's just call the exit function. Exit with the return code of 0 to stop the program. So this will make sure, like if the program did not stop, we actually have argv of 1, it exists. So this is very helpful. We won't get a runtime error now. Watch me do it wrong. It's like, oh, argc is not 2. It's set to 1 here. And so, all right, we yell at the user. Usage, argv of 0, we just got the name of the program just like this. This is how you should have run it. You said /draw square by itself. You should have said /draw square in, where n is a number. And then, all right, I get it. I'll do that. And then if you give extra stuff, it'll also complain. Any questions about that? That's useful. Prevents runtime errors. Hopefully the user actually gets a number. Yeah?
what if the user gives like a vector?
Yeah, good question. So that is up to the implementation of the A2I function. It's going to try its best to make a number out of whatever you give it. So a good default value is 0. I think it's going to get 0 if you don't see a number. Or it will try to like read up until it finds a number too. So like if I say 9 high or something like that, it will get the 9 successfully. It's going to do a best effort conversion. But yeah, I think usually the default's going to be 0 if it can't find a number. That's a good default value. Yeah, good question. Any other questions? So we're getting input before the program starts in this magical argc and argv. That's what CD's doing when you change directories. That's what G++ is doing. They're looking at these things. Now you can too. All right. Let's see here. There's totally time for this last thing. Let's do it. So here's a very complicated program that just does a bunch of fun things. So a good example, I think. So let's write a program that takes command line arguments and then also outputs them, like all of them, after doing the following. So what are we going to do to every C string in our command line arguments? Let us capitalize every single letter of that string. All right, that's the CC type library. We can use the toUpper function on each character in every C string in our command line arguments. We could do that. And then let's shift every digit. This will be fun. Let's shift every digit. So every digit that occurs, if we find one, let's change a 0 to a 1. Let's change a 1 to a 2, a 2 to a 3. And let's also make the 9 wrap back around to 0. That's going to be the hardest thing to do. So let's mess with everything in a very weird way. And so if we run the program like this, /prog blah high 42, this is what is going to be output. Let's have it output, starting from argv of 1 only. Let's have it output all caps blah. Let's translate it into that. And then all caps high, and instead of 42, let's make it 53. Right? That's how we're going to mess with everything. And so this will be some good practice. Off we go. See if you can think of the strategy before I implement it. It will take me a second. What will I call this program? We're going to capitalize and shift. So I guess that's a good name. Capitalize and shift.cpp. So I want command line arguments. So argc and argv. Argc char star argv bracket bracket. And all right, now I've got command line arguments. I want to mess with them. I want to go through all of them, not including the name of the program. Every other one though. And let's iterate through every character, right? Because I need to make the lowercase b a capital B, lowercase l a capital L. The 4-digit becomes a 5. The 2-digit becomes a 3. Okay, so that's what I'm going to do. So I need to iterate through every string in argv first, starting from argv of 1. So iterate through all the args after the name of the program. There's that. And so what does that mean? What are the indices into argv that I care about? It's for int I equals, started at 1, because that's the one after the name of the program. I is less than argc I++. So those are all the indices into argv that I care about accessing and messing with. And so, all right, at each index, let's just save it away. It's helpful. Char star, the current C string I'm working on, is argv of I. That's useful. Let's save that. And so S now is just another name for the string I want to mess with. I'm using that special char star type. That's equivalent to char bracket bracket. We couldn't use the bracket brackets here, unfortunately. So we're forced to use the star for reasons. But now I have in S, this is the name of the string that I want to mess with right now. It's the current command line argument I want to work on. All right? So S is the current command line arg I want to work on. And what will I do with it? I would like to, well, I want to go through every character, right? Process every character of S, because I need to make it all capital, and then also shift any digits along. Okay, so that's going to be my goal. So process every character of S. So I need to like go into and mess with S of 0, S of 1, S of 2, S of 3, all of the characters of the string. How many characters are there in this string? I don't know, but Sterling can tell me. I can get the size with Sterling. So every valid index into this string, or int j equals 0, starts at 0, j is less than Sterling of S. See that? J++. That'll go through every valid index of this current string. That's the current command line argument that I care about. And this is the C string library that gives me that. And then I also need CC type for checking, for converting to uppercase. So, okay, I am now inside of this loop. It's an inner loop, oh no. So S of j is my current character that I want to mess with right now. What do I want to do to it, is the first question. Well, we got to make it capitalized, right? If it's an alphabetic character, we need to capitalize it. If it's a digit, we need to shift it, okay? So let's go to CC type and see what we got to be doing here. CC type. And please shout out if you have any questions in the meantime. So CC type will do toUpper. That's where toUpper is. We give it a character, it'll give us back the capitalized character. And it won't mess with anything that isn't already, like if it's already capitalized or if it's a special character. It just won't mess with it. It'll only change and give you back a different character if it's lowercase. It will make it uppercase. So let's replace S of j with itself, but 2-uppered, and that will fix it. All right, that will make it capital if it wasn't already. So this only changes S of j if it's lowercase. Everything else, if it's any other kind of character, 2-upper is just going to give back the same thing. All right, so it's going to make it guaranteed to be uppercase if it needed to be now. So we've messed with that. And then also, we want to check if it's a digit. Because if it's a digit, we need to advance it, right? We need to change it from 4 to 5, 2 to 3, 0 to 1, all those things. So if it's a digit, shift it, and that will involve a fancy if statement. So we're still working on S of j, this current character. If S of j is a digit, shift it. And so, all right, how can we check if S of j is a digit? We have a nice, helpful isDigit function. Takes a character, gives true back if it is a digit. False otherwise. So if isDigit S of j, if that's true, we'll hit the body. And now we can work on it, right? So how do you shift a digit? Which is a little weird of a question to ask. Here's the idea. Look in the ASCII table. Man ASCII. Where is the 0 character? It's right here. It's ASCII code 48, apparently. If I want to make the 0 character a 1, I just need to make it 49. Just add 1 to it. If I want my 4 made into a 5, it was 52. I want to make it character number 53. So if I just add 1 to the ASCII value, it will shift it, usually. I will run into a problem with 9, though. It will make it a colon. So we'll fix that in just a second. But let's do that for now. So if it's a digit, then let's add 1 to its ASCII value. S of j equals whatever it was plus 1. I'm doing math on character codes. Yeah, that would also work. Definitely. And now I have messed with that character sufficiently. All right? I've messed with this entire string. I've gone through every character of it, and I'm working on all of the ones in argv. So after this, I've processed and messed with S. That was argv of I. How about we print it out now? The fruits of our labor. See how it S. What has S become? Remember, that was one of the argv strings. Let's see if I can show you most of this. There we go. That is the full loop that we care about. So see if you can follow it. You see why we needed an inner loop as well? So we're working all the characters of that string. We're going through all the strings and then working through all their characters. Capitalize and shift. Capitalize and shift. And I forgot to give a command line argument. So, all right. I want it to be, I don't know, blah and high 42. Why not? Blah, high 42. Look at this. We get blah and high 53. All caps. And it really did get shifted. The only issue is if you give like high 49, you get high 5 colon. So this is not the right way to shift the 9-digit character. It's the right way to shift everything but it, though. So if it was the 9 character, let's just handle that specially. So an if within an if. If S of j happened to be the 9 character, then let's set it to what it should have been. Make it a 0. Otherwise, our pattern still works. For every other character, just add 1 to its ASCII code. That'll fix this. Oops, recompile. Oh, did I mess something up? Oh, I forgot a semicolon. Try again. High 53, high 49 becomes high 50. Cool. Any questions about this? This is very complicated, a little weird, but a good example, I think. So iterating through all of the command line arguments, messing with those strings, doing weird C-stringy stuff. Any questions about any of that? It's a fun example to study, I think. So that is officially all that I have to tell you about arrays and vectors. You made it. It was a 3-lecture series, so good job getting through it. We did it. Now, let's see what else is there to do for the day. It was just that. So no new lab. You already have one that's going to be due later. Please do it. It's your loops lab. I'm going to be asking about loops on the test, so get practice with that before it's due. But yeah, the rest of the time is yours to work and ask questions. I got nothing new.